Okay, if you need help on questions that deal with substitution type problems, look no further. That's what I'm going to talk about in this video here today. So we're going to look at word problems with systems of equations where we're comparing two variables, okay? And what that will mean is you'll see something in the problem that says something like the number of kittens is twice the number of puppies, or you'll see something like the length is twice the width, or something is 1/2 of something else. So when you're not totaling things, so we talked about the totals in a previous video, where they say the total amount of money that was, spent is $39. That would go in for C, and you kind of fill in this stuff over here. When you're comparing the variables, think it's going to be a substitution setup with an isolated variable. So you'll take one of your variables and set it equal to something. All right, let's take a look. Mike has totaled 66 points so far this season. I'm going to actually highlight that. He has only made 2-point and 3-point baskets, no foul shots, and has made five more than twice as many 2-point shots as 3-point shots. How many 3-point and 2-point shots has Mike made this season? I'm going to start these problems like I start pretty much all word problems with a let statement, identifying what we're trying to find here. And in this case, again, it's usually in the last sentence. It asks us how many 3-point and 2-point shots has Mike made. So we'll let X equal the number of, let's go with 2-point shots for X. And we'll let Y equal the number of 3-point shots that Mike has made. Okay, and now that we're here, we're getting closer. We've got to go ahead and now write our two equations. So to write out these two equations, if we look here, this first one's going to be something you're familiar with if you watched the last video. That keyword is totaled. So in this case, I know that I have a total of 66. Something should equal 66. Okay, now if I want to look at this, this is 66 points, and I know that points plus points should equal points. So if I look in the problem here, if I take 2 points times the number of 2-point shots he's made, plus 3 points times the number of 3-point shots he's made, we've got the points from 2-point shots plus the points from 3-point shots should equal the total points, and that's going to make sense here. So points plus points equals points. That'll take care of the total. Now the new thing here is this other part. This does not deal with the total, this information below, this 5 more than twice as many 2-point shots as 3-point shots. When I get to a problem like this, what I'll do is I'll try to first identify which one there's more of. So if I look through, I see 5 more than twice as many 2-point shots as 3-point shots. Okay, so that means he's made more 2-point shots. So I'm going to take the 2-point shot variable, which is X, and isolate it. I'm just going to put X equals. The next thing I'm going to do is I'm going to sneak a Y over here, and I'm going to think about what do I have to do to Y so that it equals X. And the key here is first we need 5 more than twice as many. So we need twice as many and then 5 more. So he's made 5 more than twice as many 2-point shots as 3-point shots. And if you're thinking that this is backwards, that the Y should be here and the X is here, here's a quick way to check your answer. Plug in, let's say, 1 for Y. Okay? If you take 2 times 1 plus 5, you get 7. Notice that there are more 2-point shots than 3-point shots when I plug 1 in. Okay? That's a way you can kind of check to make sure you're doing that right. A lot of people do these backwards. They'll put the X and the Y in the wrong spots for those. Okay, and now from here, look at this. This is a great setup for substitution. We've got an isolated variable. So I'm going to take the X, which is isolated, and replace this X up here with 2Y plus 5. So we'll take 2 times the quantity 2Y plus 5 plus 3Y is equal to 66. And then if I distribute, I'll get 4Y plus 10 plus 3Y is still equal to 66. If I combine like terms, I'm going to get 7y plus 10 is equal to 66. And then finally, I'm getting 7y equals 56, which tells me that y is equal to 8. So we found the one coordinate, and again, we said that in the previous video that, having 8 is not really a great answer. Let's kind of say what this is. So that would be 8 3-point shots. So he's made 8 3-pointers so far. Maybe I'll put a little dash here so we can keep those numbers separate. So 8 3-point shots. And now to find the number of 2-point shots, again, we know that there should be more of these. Let's just make sure that's the case. If we plug in 8 for y, we should be getting that x is equal to 2 times 8 plus 5. 2 times 8 is 16, so we get 16 plus 5, which tells me that we've got 21 2-point shots. So the number of 2-point shots, we got 21 2-point shots. Again, to check your answer, you can plug the x and the y back in for both equations to make sure that works, or you can just kind of read the problem and see if it makes sense. Sometimes that's a better way to check it. And what we'll do is we'll circle that answer. That would be a good way to write the answer there. So 21 2-point shots and 8 3-point shots are how many points that Mike has, or how many shots Mike has made this season. Okay, next one. We've got a perimeter question here. It says the perimeter of a rectangle is 52 inches. The length is 3 less than twice the width. Find the dimensions of the rectangle. Once again, I'm going to start with a let statement. Let x equal something. Actually, you know what? In this case, I won't even use x and y. I'm going to switch it up here. So it says find the dimensions of the rectangle. If I have a rectangle, then the two dimensions of the rectangle would be the length and the width. So what I'm going to do is I'm going to let L equal the length, and I'm going to let W equal the width. You really don't have to use x and y. I've been doing that, but really, I mean, you can let these be whatever you want. I think sometimes it's less confusing to use letters that make a little more sense to the problem. So we've got the perimeter of a rectangle is 52 inches. The length, and I'm going to start here, I think, on this one. It's the one most people see first. The length is 3 less than twice the width. Once again, this is a comparison of variables. We're not looking at some sort of total here. We've got the length is, and actually when you think about it, is often means equal. So the length is 3 less than twice the width. Well, that would be written as 2w minus 3. Remember that less than means you change the order, so the minus 3 has to come at the end. That's one equation. We've got L is equal to the length is 3 less than twice the width. That'll take care of that. Tricky part is going to be this one. That the perimeter, this is actually an equation right here. The perimeter of a rectangle is 52 inches. Now let's think for a second. If you think back to perimeter, perimeter is all the sides of a figure added up, basically the total distance around the figure. So, or how much fencing we would need to enclose this rectangular fence if I had it in this case. So in this case, if you think about it, if I added up all these sides, I'd have 2 W's and 2 L's. So you may remember that formula that the perimeter of a rectangle is 2 lengths plus 2 widths. Now, we have our L's and W's already in the formula. All I really need to do is plug something in for P. If you look here, they told us that the perimeter is 52 inches. So let's actually go ahead and plug that in right now. So we could write this second equation as 52 perimeter is equal to 2L plus 2W. That's kind of like a totaling problem. You have the total distance around the figure, so 2 lengths plus 2 widths should give you the total distance around. And now from here, again, it's going to be just a little bit of solving. We're going to have to take the L and substitute it in for this L here. So we'll have 52 is equal to 2 times, and I've already wrote that down. I'm just going to fill in the 2W minus 3 here. And if we distribute, we're going to get 52 is equal to 4W minus 6 plus 2W. If I add the 6 over, that gives me 58 is equal to, and I'm going to combine these like terms. I know I'm skipping some steps here, but this should be 6W. We added the 6 over and combined the like terms. And then if I divide both sides by 6 here, I should be coming up with W is equal to 9 2/3 inches. Probably the best way to write it here would be a mixed number. Decimals, when you're measuring things, usually you use mixed numbers. So 9 2/3 inches for my width. Let's go ahead and plug in to find the length. So we're almost there. We just need to find the other dimension, which is the length. So the length, we'll use this top equation. It's going to be our best bet. It's a whole bunch easier to use that. So we'll take that the length is equal to 2 times W minus 3, and we know that W in this case is 9 2/3, so we'll fill that in. Okay, and if we go ahead and solve all this out, we should be getting that the length is equal to 16 1/3 inches. So what we've got here are my two dimensions. So I'm going to go ahead and probably write this way, that the dimensions are, so they asked us what the dimensions are. The dimensions are 9 2/3 inches by 16 1/3 inch. Okay, so those would be the dimensions of the rectangle. You could write the word by if you don't like seeing the multiplication symbol here. That works too. You could use the double line inches symbol, whatever. But it's a good idea to write your units out and just kind of make sense of the problem. Don't just leave it as an ordered pair. Don't just don't just write the numbers down without the units. But again, this is an introduction to substitution type problems. We're looking for things that compare the variables. So the length is 3 less than twice the width. That's an example of when you're going to have an equation that has an isolated variable. Another one here, again, giving you an example, would be 5 more than twice as many 2-point shots as 3-point shots. Whatever we're looking for, if it's being compared, then we're going to look at some sort of isolated variable. Okay, so think that x equals or something equals your number.